All right, we're back to finish up chapter 11 with a discussion of aromatic compounds very briefly. So aromatic compounds, exactly what it sounds like. These compounds tend to have a be very fragrant. So you notice them when they're around because they have a very strong nose sense. Um, the first one that was isolated was benzene here. And it was really a puzzle for scientists for a long time because they came up with the molecular formula C6H6 for benzene, but that didn't make any sense. No one could come up with a reasonable structure, and it took a long time of arguing about it to come up with what it actually is. So benzene is, it's an aromatic compound, and it's the simplest one. And it is a ring of 6 atoms, okay? So it looks like a cyclohexane first. But then the way we draw it is we actually draw it with 3 alternating double bonds. So you can draw it like this. Sorry, those double bonds are pretty bad. You can draw it like this, or you could draw it the other way here, which is a double bond here, here, and here. And believe it or not, these are equivalent structures. Because as it turns out, these double bonds, if you take a super microscope and look down at a ring of benzene, it turns out it's not that there's 2 sets or 3 pairs of them that are closer and then farther apart. The double bonds should be closer. The single bonds should be farther apart. That's not what we see. Instead, they're all equally far apart. So these 6 electrons are all shared equally between them in the ring. It's a principle called resonance. We didn't really discuss much in this class because, again, we just don't have time for everything, unfortunately. But benzene, nonetheless, a very fascinating compound. And this aromatic ring structure is extremely important biologically. Many of our biomolecules contain these ring structures. So anything, for example, with a phenylalanine, and there's another amino acid that's got an aromatic structure. Tryptophan has an aromatic structure. There's a lot of amino acids that have this, and then it's baked into, for example, steroids. So things like cholesterol and other steroids have an aromatic structure. So it's sort of baked into life because it's such an important structure in carbon chemistry. So yeah, so you can represent it equally with either of these structures here. And oftentimes what we end up doing is, rather than worrying about drawing those triple bonds, we'll just draw a cyclohexane and then put a circle in the middle. And that'll be the difference. That'll say, okay, this is benzene. And importantly, it turns out that the chemistry of benzene is a lot different from the chemistry of cyclohexane. And that's really important. There's basically more electrons to go around, so it can be more reactive, participate in more reactions. Now, there's some of these that we need to know, and we just have to memorize as far as like the names of them. So benzene itself, of course, there's no way you would know that. We call it benzene. That's what this is. Now, if you take a benzene and you add a single methyl group, then it's called toluene. This is important because toluene, again, is a very common, just like benzene, it's even actually more common than benzene as a solvent. So people use it in a lot of industrial processes. So if, for example, let's say that you're treating a patient that gets poisoned, you may need to know, oh, it's toluene. This is what toluene is, which is a benzene ring with a methyl group on it. Now, benzene is not commonly used in industrial applications because it's extremely cancerous. So you don't want to actually be exposed to benzene. It's just sort of a useful starting point for all of these aromatic compounds. Then we have 2 others that are important, mostly as solvents. We have aniline here, which is a very fishy smell. And aniline is a benzene ring that's bonded to an amine group, which is just NH2. We'll talk more about amines in a future chapter. And then phenol is a benzene ring that's bonded to an alcohol group, the OH group that we were just talking about. Okay, so those are ones that you just have to memorize, right? Benzene, just straight benzene ring. Toluene is methyl benzene. Aniline is an amine group on benzene, and then phenol is an alcohol group on benzene. Okay, now, if you have 2 or more substituents, the way that you name it is you just name those substituents, And you give always the lowest numbers to the substituents that you can. So for example, if you just have a single chlorine, it's easy enough. You can just call it chlorobenzene. We know the chlorine is going to be on carbon 1. If you have 2 chlorines, well, then you're going to number it so that those numbers are the smallest as possible. So here, this would be 1,2 dichlorobenzene. I compare here 1,3 dichlorobenzene, and here 1,4 dichlorobenzene. And then what we can do if we have a toluene, phenol, or aniline with substituents, you just assume that whichever carbon has the amino, the hydroxyl, which is the alcohol, or the methyl group, for toluene, phenol, or aniline, that's going to be carbon 1. And then the other substituents are going to be numbered from there. So like here, this is clearly aniline. It's an amine group on benzene. And then we just count over 1, 2, 3. So we have a bromo on carbon 3. So it'd be 3 bromo aniline. Same thing here for phenol. Phenol has an OH group. We know this is carbon 1. So then we have chloro on carbon 2 and bromo on carbon 4. And then here, you don't really have a choice. You're going to have to number all 6 of them here. You could choose either way because it's symmetrical, but we have to start with carbon 1 on the methyl group. So this is toluene, carbon 1 here. So then it's 2, 6 dibromo for chlorotoluene. Okay, so some other common aromatic compounds. I know we've already talked about this a little bit, but for example, trinitrotoluene, you may know it better as TNT, which is an extremely strong explosive. These nitro groups are very reactive, and that's why that's the case. Now, not all of them are so toxic. There's also acetaminophen, for example, which is a painkiller, just like aspirin here, containing the benzene ring. And then finally, vanillin is I believe that's the artificial vanilla flavoring. Although actually it might be the natural one too. I can't remember if there's a difference between those two. But vanillin and cinnamaldehyde, I think, also includes a benzene ring. These are all examples of aromatic compounds. Okay, so let's go ahead and give it a shot. Now, for these, I am going to be giving you guys a little handhold here with the multiple choice questions. I'll make sure that you have the same thing on the exam, just because it's not going to come up too much, but I will expect you to be able to recognize, for example, toluene, benzene, aniline, and phenol, because they're going to be very important compounds just in the real world. But go ahead, name 1 and 2, and then I think we'll be done with this chapter. So give it a shot, pause the video, and when you come back, we'll have the answers. Okay, let's check it out. So first up, we have a chloro group on a benzene ring. That's chlorobenzene. Next up, we have 2 methyl groups here. So you just number one of them 1, the other one 3. Could be 1,3-dimethylbenzene. You could also call this 3-methyltoluene, I suppose, if you wanted to. I would accept that as well. Okay, all right. Well, that does it for chapter 11. I think we're ready to move on to chapter 12. And we're going to talk more about different types of organic compounds in there. Make sure finish the homework for chapter 11 and ask in the comments below if you have any questions. All right, see you later. Bye-bye.